When reading a box and whisker plot, there's some important information that we need to be able to pull from the data. Specifically, we need to understand what the 5-number summary is. As I look at this box and whisker plot, the number all the way to the left will always represent your minimum value, and the number all the way to the right will always represent your maximum value. The number in the middle is always going to be your median, and the two numbers that edge the corners of your box are going to be Q1 on the left and Q3 on the right. Some specific information that we'll be asked to analyze then is, first, the range of the data. The range is always going to be the max minus the min. So no matter what the data set looks like, if you're asked for the range, take your maximum value, in this case 96, and subtract your minimum value, in this case 61. On this particular box and whisker plot, my range is 34. So my range in here is 34. Interquartile range is slightly different. In this case, I'm not taking the max minus the min. I want to know in the interquartiles what the range is. The interquartile is our box up here. So we're looking just for the range of that information. So in this case, I'm going to take Q3 and subtract Q1. For this data set, that's 84 minus 73, and 84 minus 73 gives me an interquartile range of 11. So for this data set, our range is 34, and our interquartile range is 11. One of the nice things about plotting data this way is we actually do have 4 distinct sections of our data. One is between the minimum and Q1, a section between Q1 and the median, a section between the median and Q3, and then the section between Q3 and the max. What's true about each of these sections is that if we looked at the data set in whole, approximately 25% of your data would fall in between the minimum and Q1. Approximately 25% of your data would fall between Q1 and the median, 25% here, and 25% here. We only say approximately because sometimes if Q1 happens to be one of the numbers that's in the data set, it might be slightly less than 25% in here or in here. But essentially what we're looking at is the data set is split perfectly in quarters. So you may be asked how much of the data set falls between the minimum and the median. It's a matter of adding up 25% and 25% to say 50%. Or how much of the data set falls between Q1 and the maximum. It's this 25, and this 25 for a total of 75% of the data would fall in between the Q1 and the maximum. Now we just jump to a new graph here. It's still box and whisker, but this one does look a little bit different. And the major difference here is our outlier. If you notice, these numbers are scrunched in fairly tight. 8 to 19 isn't a very big spread. But then we skip all the way over to 82. If that's what happens, we would consider 82 an outlier. It falls way outside of the data range. It doesn't change the fact that this still represents about 25% of the data. This represents about 25% of the data, 25%, and 25%. Even though this line looks a lot longer, It's just because of how far spread apart 19 and 82 are compared to 15 and 19. The way that we calculate range and interquartile range doesn't change. In this case, my range is going to be 82 minus the 8 for a range of 74. But my interquartile range is 19 minus 12, or 7. When we have heavy outliers, either on the maximum or with the minimum, this is what we'll typically see, a big spread between our range and our interquartile range. It doesn't mean that's the only time we see that, but we do tend to see that when we have outliers.